13,000 years ago, in the subtropical forests of central Mexico, the avocado faced a survival problem that no plant can solve on its own. Its fruit was large, fleshy, rich in fat, and perfectly designed to be eaten. The problem was the seed. The pit of a ripe avocado measures between 3 and 4 centimeters across. For a plant to reproduce through an animal, that animal must swallow the seed whole, digest the fruit without destroying it, and deposit the seed somewhere else where it can germinate. An avocado pit is too large for any animal living in Mexico today to swallow whole. Spider monkeys reject it, peccaries chew it to pieces, and jaguars do not eat it. For the avocado to reproduce in this way, it needs an animal that no longer exists. What the avocado needs is a mammoth, a mastodon, a gonphotheres, one of the dozens of megafaunal species that inhabited the Americas 13,000 years ago and vanished within a geologically brief interval. The gonphotheres, an extinct relative of the elephant that lived in the Americas for millions of years, had the right size, digestive tract, and feeding habits to serve as the avocado's ideal seed disperser. So did the giant ground sloth, an animal the size of a car that fed on fruit and could swallow seeds as large as a fist. These animals did not disappear gradually. They vanished over the course of a few thousand years, and some species perhaps within only a few centuries. Scientists attribute that collapse to climate change at the end of the Ice Age and the arrival of the first human hunters. The avocado should have gone extinct with them. Without a disperser capable of swallowing its pit, the fruit would ripen and fall beneath the parent tree. Its offspring would compete with the parent for the same resources in the same soil, beginning a spiral that biology predicts will end in the species' local extinction. What prevented that fate was not a biological accident, but the arrival of another kind of animal at precisely the critical moment, the human being. The avocado's evolution as a fruit began at least 7 million years ago, when its earliest botanical ancestors were already producing large seeded fruits in the forests of what are now Mexico and Central America. Over those millions of years, coevolution between the plant and its seed dispersers shaped the fruit into the form we know: larger, fleshier, richer in fat, and carrying a larger seed. More fat means more calories per unit of volume, making the fruit more attractive to animals that need to store energy. A larger seed means an embryo with greater nutritional reserves at germination, giving the offspring an advantage during its first weeks of life. The avocado's fat content, between 15 and 25% depending on the variety, is extraordinarily high for a fruit. Most fruits are rich in sugar and low in fat. Because sugar attracts the birds and primates that disperse them. The avocado is the most striking exception, richer in fat than in sugar, and closer in composition to a nut than to an apple or orange. This composition is no accident. It is the result of millions of years of selection by large animals whose metabolisms demanded the caloric density that only fat could provide. Paleontologists call this an evolutionary anachronism, a trait that outlived the animals for which it was selected and appears to serve no function in the modern world. The avocado is the classic example, but the same is true of the soursop and other large-seeded American fruits that were probably dispersed by megafauna and now grow in places where no living animal can perform that task. They are relics of a world that preceded our own, fruits designed for an ecosystem that ceased to exist 13 millennia ago. Coxcatlan Cave in the Tehuacan Valley of the Mexican state of Puebla is one of the most important archaeological sites for understanding the history of food in the Americas. In its sediment layers, archaeologists found evidence of human avocado consumption dating back 8 to 10,000 years before the Common Era, just as the American megafauna was disappearing or had already disappeared. The people of that valley ate wild avocados and carried the seeds during their seasonal migrations. Probably without any conscious intention, they became the new dispersers of the seeds that gonphotheres could no longer spread. This transition from megafaunal disperser to human disperser is one of the most extraordinary moments in the botanical history of the Americas. The first people who ate wild avocados in the Tehuacan Valley did not know they were saving a species from extinction. They ate because they were hungry and because the fruit was nutritious. They discarded the seeds, or passed them, in places far from where they had eaten the fruit. In those new locations, some seeds germinated and produced trees that otherwise would never have existed. The species survived because its new relationship with humans functionally replaced its lost relationship with the gonphotheres. The difference between a megafaunal disperser and a human one is enormous. The gonphotheres spread seeds because avocados were part of its diet, and its digestive tract was the dispersal mechanism. Early humans spread them because they used avocados as food, and their movements carried the seeds into new territories. But the biological result was similar: avocado trees growing in places they could never have reached on their own. Over time, the relationship became more active. Humans began selecting trees that produced the largest and richest fruit, transplanting them near their settlements and saving seeds from the best specimens. The avocado was domesticated, and domestication saved it. Domesticating the avocado was more complicated than domesticating most American crops, because a tree grown from seed takes between 3 and 10 years to produce its first harvest. Farmers who devoted land and care to an avocado tree were making a long-term investment whose rewards might be collected by their children or grandchildren. This biological trait had important cultural consequences. The peoples who domesticated the avocado necessarily possessed systems of ownership, inheritance, and intergenerational continuity that made such an investment possible. Avocado domestication presupposes a sedentary or semi-sedentary society with concepts of territorial ownership that pass from one generation to the next. In purely nomadic hunter-gatherer cultures, planting a tree that will take years to bear fruit makes little practical sense. In this respect, the domesticated avocado is indirect evidence of the social complexity of the cultures that cultivated it. Domesticating the avocado was more complicated than domesticating most American crops because a tree grown from seed takes between 3 and 10 years to produce its first harvest. Farmers who devoted land and care to an avocado tree were making a long-term investment whose rewards might be collected by their children or grandchildren. This biological trait had cultural consequences. The peoples who domesticated the avocado necessarily possessed systems of ownership, inheritance, and intergenerational continuity that made such an investment possible. Avocado domestication presupposes a sedentary society with concepts of territorial ownership that pass from one generation to the next. In purely nomadic hunter-gatherer cultures, planting a tree that will take years to bear fruit makes little practical sense. In this respect, the domesticated avocado is indirect evidence of the social complexity of the cultures that cultivated it. The earliest evidence of cultivated avocado, distinguishable from the wild fruit by the size of its seed and its presence in domestic contexts, dates back roughly 5,000 years at sites in Mexico and Central America. Avocado domestication was not a single event or a deliberate discovery. It was the gradual accumulation of practical decisions. Plant closer to home, select the largest fruits, protect the most productive trees, exchange seeds with neighboring groups. Over millennia, this quiet, incremental process transformed the wild avocado into the cultivated fruit the Spanish encountered in the 16th century. 16th century Spanish colonial medicine enthusiastically adopted some American plants and rejected others, and its criteria were not strictly medical. European physicians tended to embrace plants they could fit into the galenic humoral system, hot, cold, moist, and dry, that dominated Western medicine. The avocado was difficult to classify. Its high fat content did not fit comfortably into the humoral framework. The properties attributed to it by Aztec healers were too closely bound to Aztec cosmology for Spanish physicians to accept. As a result, the avocado remained outside the European colonial medical system for 2 centuries, even as indigenous medicine continued to use it without interruption. For the civilizations that developed in Mesoamerica during this period, the Olmec, Teotihuacan, Maya, and Aztec, the avocado was not simply a food. It formed part of systems of belief, ritual calendars, and medical practice. The avocado tree appears in the murals of Teotihuacan, the largest city in the Americas around 400 CE, depicted in contexts suggesting associations with fertility and abundance. The murals of Tepantitla, within the archaeological zone of Teotihuacan, show a figure some scholars identify as the rain god Tlaloc, surrounded by fruit trees that appear to include avocados. The Nahuatl word ahuacatl carried two meanings that coexisted without apparent contradiction in the language or the culture. The first was the name of the fruit. The second was the anatomical term for a testicle. To an Aztec observer, a tree bearing fruit in hanging pairs had an obvious visual resemblance to male anatomy, and the language captured both with the same word. This double meaning was neither a joke nor a euphemism. It expressed a conceptual connection among the fruit, fertility, and sexual potency that 16th century chroniclers recorded with a mixture of fascination and scandal. The Aztecs consumed avocados in several ways, documented by Spanish chroniclers with varying levels of detail and accuracy. The simplest preparation was merely ripe fruit mashed with salt and chiles, essentially the same preparation as modern guacamole. 16th century texts also describe avocado oil used for cooking, the tree's leaves used as an aromatic seasoning, and the ground seed used as a blue-black dye for cloth. The bark was used in medicinal preparations for digestive problems and skin conditions. The avocado's medicinal applications in traditional Mesoamerican medicine were extensive and detailed. The Badianas manuscript of 1552, the first herbal of the New World, compiled by the Aztec physician Martín de la Cruz, mentions avocado in treatments for several conditions, as a remedy for dandruff, for toothache, and as an ingredient in preparations intended to improve fertility. The connection between avocado and fertility, established in language through the double meaning of ahuacatl, was also expressed in medical practice through prescriptions that used the fruit in reproductive contexts. In the Aztec ritual calendar, the 260-day Tonalpohualli, the avocado had specific associations with particular days and periods of the cycle. And in the 365-day solar calendar, one of the 18 20-day months was associated with the season when avocados ripened and rituals of thanksgiving for the harvest were performed. The avocado's integration into Aztec systems of time and ritual reflects the plant's central place in both everyday and ceremonial life. It was not a marginal supplement to the Mesoamerican diet. It was one of its pillars. The first European to describe the avocado in writing was the geographer and conquistador Martín Fernández de Enciso in his Suma de Geografía, published in 1519. Enciso's description is brief and practical. He mentions a large fruit with a seed inside and a buttery flavor, highly prized by the indigenous people. Gonzalo Fernández de Oviedo devoted several paragraphs to the avocado in his 1527 General and Natural History of the Indies. He described the tree, fruit, and seed precisely enough to make identification unmistakable. Fernández de Oviedo was the first to note something every later chronicler would confirm. The fruit was extraordinarily nutritious, and Spaniards took time to acquire a taste for it. This Spanish resistance to the avocado is one of the most interesting phenomena in the history of colonial food. The Spanish conquistadors and colonists who arrived in Mexico during the 16th and 17th centuries adopted maize, tomatoes, chiles, cacao, and vanilla relatively quickly. The avocado was different. For at least 2 centuries, it was regarded as indigenous food, a marker of identity separating colonizers from the colonized, and people avoided it precisely because of that association. There were several reasons for this resistance. The avocado's flavor, rich, mild, neither sweet nor sharply acidic, fit no familiar category in Spanish culinary experience. The fruits Spaniards knew were either sweet or sour. The avocado was fatty, closer in texture and composition to butter or oil than to any Mediterranean fruit. Its texture was equally unfamiliar, soft and unctuous, dissolving in the mouth in a way that had no equivalent in Iberian cooking. The sexual double meaning of its Nahuatl name, repeated by chroniclers, added a connotation that made the fruit morally suspect, as well as culinarily strange, within the culture of Spanish colonial morality. The avocado's spread around the colonial world was uneven not only geographically, but also in terms of the knowledge that traveled with the plant. In Mexico and Central America, the full body of knowledge was transmitted: how to grow it, when to harvest it, and how to use the leaves and seed as well as the fruit. Where it arrived as a novelty, the Caribbean islands, the Canaries, West Africa, and the Philippines, it arrived primarily as a fruit, accompanied by only partial knowledge. That difference shaped how it was adopted in each place. In the Philippines, it entered local preparations with no Mexican equivalent. In West Africa, it was combined with local cooking techniques. In the Canary Islands, it took centuries to become an everyday food. It was not enough for the tree to arrive. Knowledge of how to cultivate and prepare it had to travel with it. The colonial food hierarchy established in Mexico during the 16th, 17th, and 18th centuries was as much a system of social classification as a culinary one. Foods of European origin, wheat, beef and pork, wine, olive oil, were considered superior and reserved for the colonizers. Foods of indigenous origin, maize, chiles, avocados, unsweetened cacao, were classified as Indian food, suitable for the indigenous population, but not for Spaniards of social standing. This classification was not merely cultural. It had real economic consequences. European products were produced and traded through networks controlled by colonizers, while indigenous products circulated within local economies that were less integrated into the colonial system. For more than 2 centuries, the avocado remained trapped on the indigenous side of this divide. Creoles, Spaniards born in the Americas, adopted it earlier than people born on the Iberian Peninsula, probably because they grew up where indigenous cooking was more pervasive. By the 18th century, the avocado had become a familiar part of Mexican Creole cuisine, which combined European and indigenous techniques and ingredients in proportions that varied by region and by the cook's social status. In Spain and the rest of Europe, however, it remained virtually unknown, or was known only as a botanical curiosity brought from the New World. This stands in sharp contrast to the tomato and the chile, which reached Europe in the 16th century and were adopted relatively quickly, especially in Italian and Spanish cooking. The most likely explanation is the one chroniclers repeatedly gave. The avocado's taste and texture were simply too foreign to European culinary experience for immediate acceptance. The tomato was acidic, and acidity was familiar. The chili was hot, a variation on a sensation people already knew. The avocado was fatty in a way that had no equivalent. While Spanish colonists resisted the avocado, European empires were transporting it around the world through their trade networks. The Portuguese brought it to Brazil in the 16th century, and from there it spread throughout the rest of South America over the following centuries. The Spanish introduced it to the Canary Islands, a stopping point on routes between the Americas and Europe, and from the Canaries, the tree traveled to other Atlantic territories. By the 17th century, the avocado had reached the Caribbean islands, the Philippines by way of the Manila Galleon, and several regions of West Africa where the Portuguese had established trading posts. The avocado's spread through Africa is one of the least familiar chapters in its history. In several West African countries, Ghana, Nigeria, Cameroon, and Côte d'Ivoire, it became a fruit tree cultivated by local communities in household gardens. Its adoption was quiet and gradual, without the documentation colonial chroniclers produced for other products of the Columbian exchange. By the 19th century, the avocado was already a familiar tree across large parts of sub-Saharan Africa, eaten in ways similar to those of Mesoamerica. The ripe fruit mashed as an accompaniment to other foods, or eaten on its own with salt. In Asia, the avocado arrived by several routes and at different times. The Philippines, a Spanish territory linked to Mexico by the Manila Galleon, received it relatively early. Indonesia adopted it through Dutch trade networks. Sri Lanka received it from the Portuguese. In each Asian setting, the fruit found different uses. In some countries, it was eaten ripe with sugar rather than salt and treated as a sweet dessert fruit. In others, it entered savory preparations. This divergence reflects the absence of an existing tradition governing how avocado should be eaten. Each culture had to answer that question for itself. The transformation of the name along these journeys is a story in its own right. The transition from the Nahuatl ahuacatl to the Spanish aguacate was direct, involving the kind of phonetic simplification common when one language adopts a word from another. But throughout much of South America, the avocado also has another name, palta, which comes from Quechua, the language of the Inca Empire, following the Spanish introduction of the tree into Andean territories. English took a more circuitous route. Avocado derives from a corruption of aguacate, avogato, then avocado, which English speakers associated originated with their own word, advocate. The fruit that meant testicle in Nahuatl became, through phonetic accident, a lawyer in English. In 1926, a mail carrier named Rudolf Haas lived in La Habra, California, and had an avocado tree in his yard, grown from a seed a nurseryman had sold him for 75 cents. The tree produced fruit unlike the varieties then known in California. Its skin was darker, turning almost black when ripe, and rough and pebbled rather than smooth. Haas thought the tree was defective and nearly cut it down several times. His children stopped him because they liked the fruit. In the end, he let it stand. Without knowing it, Haas possessed a spontaneous genetic mutation that produced an avocado variety with unique characteristics. The dark, rough-skinned fruit ripened more evenly than smooth-skinned varieties. It kept better after harvest. It was more resistant to transport, and its flavor was richer and more consistent than that of competing varieties. Haas patented the tree in 1935, the first patent ever granted for an avocado variety, and began selling grafts. During its early years, the Haas struggled to gain a foothold in a California market dominated by the smooth-skinned varieties consumers already knew. Haas's 1935 patent marked a milestone in the history of agricultural intellectual property. Before Haas, no one had attempted to patent an avocado variety. He received plant patent number 139 in the United States, granting him exclusive rights to the variety's vegetative propagation for 17 years. While it remained in force, California growers who wanted to plant Haas trees had to obtain a license. When the patent expired in 1952, anyone could propagate the variety freely. That is exactly what happened, on a scale Haas did not live to see. The year his patent expired was also the year he died. The variety spread through California, Chile, Mexico, Spain, South Africa, and Israel, without the man who discovered it ever accumulating the wealth his discovery would generate in the decades to come. Haas's patent expired in 1952 without making the mail carrier especially rich. The mother tree, the original tree in La Habra, was cut down in 2002 after dying from Phytophthora cinnamomi, the same disease that threatens avocado trees around the world. But its descendants, multiplied by grafting, were already distributed throughout every avocado-producing country. Today, roughly 90% of the avocados produced worldwide are Haas or Haas-derived varieties. All of that production is genetically descended from the single tree in a California mail carrier's yard that was nearly cut down several times because its owner believed it was defective. This genetic concentration has a biological dimension growers understand well. Every Haas tree in the world is a clone. They carry exactly the same genetic material because they are reproduced by grafting, not from seed. That means they share exactly the same strengths and exactly the same vulnerabilities. A pathogen that learns to attack the Haas, like the Phytophthora that killed the original tree, could, in principle, attack global production all at once. The genetic biodiversity the avocado accumulated over millions of years of evolution in the wild has been replaced in commercial production by the genetic uniformity of a single variety, selected by a California mail carrier less than a century ago. The history of the avocado is the history of an organism that survived the extinction of the animals that made its existence possible. It was domesticated by the peoples who arrived to replace them. Over millennia, it built a relationship with Mesoamerican cultures that integrated it into their cosmology and calendar. It was stigmatized by colonizers who did not understand it. It traveled the world, acquiring different uses and different names. And it ultimately became concentrated in a single variety, descended from one tree in a California yard. What that La Habra tree contained in its genes was the result of 10,000 years of human selection, acting on a plant that was already 7 million years old when the first people encountered it. The seed Haas bought for 75 cents carried that entire history inside it. Coevolution with gonphotheres, the hands of the people of Xochicatlan, the gardens of Aztec priests. Mail carriers do not usually change the history of agriculture. Haas was the exception, and he became one simply by refusing to cut down a tree his children wanted to keep. The avocado reached our present from the Pleistocene, saved from extinction by the first humans who entered the Americas as the world of the mammoths was fading away. The fruit that should have vanished with the American megafauna is now the fastest-growing fruit crop in the world. Biology guarantees no destiny. What survives and what disappears depends on chance encounters between species, and between species and humans that no one plans and no one can predict. There is one aspect of the avocado rarely mentioned in historical accounts that deserves attention: the extraordinary genetic variation of the wild species. Botanists cataloging wild avocados in southern Mexico and Central America have documented hundreds of local varieties, each with distinct characteristics of size, flavor, fat content, ripening season, and disease resistance. This diversity is the result of millions of years of evolution under very different conditions, different soils, elevations, and climates, which produced locally adapted populations with unique traits. This genetic variation was the raw material from which Mesoamerican peoples selected the cultivated avocado. It is also the resource agricultural geneticists have used since the 20th century to develop varieties resistant to disease, pests, and difficult climatic conditions. Germplasm banks preserving wild avocado varieties are biological reserves of incalculable value. They contain adaptations the species developed over millions of years, adaptations that may be needed to overcome challenges the Haas monoculture cannot meet on its own. Wild avocado still survives in the forests of southern Mexico, Guatemala, and Honduras, although in ever smaller areas as deforestation advances. These wild trees are the direct relatives of the plants eaten by the people of Cuscatlan 10,000 years ago. Descendants of trees whose seeds gonphotheres spread for millions of years before humans arrived. Their continued existence is another accident of history, another case of the improbable survival of something that should not have survived. The biology of the avocado is ultimately the biology of improbability. It was improbable that a fruit designed for extinct animals would survive their disappearance. Improbable that the first humans to reach the Americas would encounter that fruit at the precise moment a new disperser was most urgently needed. Improbable that thousands of years of cultivation and selection would produce not one, but hundreds of distinct varieties. Improbable that a California mail carrier, by refusing to cut down a tree his children wanted to keep, would create the variety destined to dominate global production in the following century. The chain of improbabilities connecting the Pleistocene to the Haas is so long that if any link had failed, the avocado simply would not be here. And yet, it is.